let's use the normal distribution to find unknown values. First, let's revisit the normal distribution. So if we think about the normal distribution where the z-scores are located across the bottom axis here. So if we cut this directly in half so the left and right side are symmetrical, that has a z-score of 0. As we move to the right, we have a z-score of 1, 2, 3. Hopefully this looks familiar and that you've dealt with, that's a 3, the normal distribution at some point before. Now, the point of z-scores and normal distribution is that if we normalize or standardize values, it allows us to do a better comparison. Like, you've probably heard people say we can't compare apples to oranges. Well, if you turn everything into a z-score, then you can compare. Now, when we're dealing with the normal distribution, if we talk about area under the curve, we talk about this as probability. So the entire curve altogether equals 1 because it's the entire thing. But if we would just break part of it, then it becomes probability, right, somewhere between 0 and 1. So we are going to use the normal distribution idea of z-scores and all of that in order to find unknown values. So let's just go with a basic example. We have the normal distribution part of the table here that we're going to need. The mean is 24 with a standard deviation of 2.5. If the unknown value is in the 89th percentile, what is the unknown? Well, unknown value. So we know the mean is 24, the standard deviation is 2.5, and 89th percentile. That means the probability is 0.089. Now, if you recall from this table, the inside pieces here, these are all probability, okay? So if we know that we are in the 89th percentile, we are looking for 0.89 inside of the table here. So this right here is the value closest to 0.89. Now, if we have that, we can say, okay, to find the z-score, we go up and back. So you'll notice that over here we have 1.2, and then over here the last number is 3. So this is our z-score of 1.23. That is not the answer. That is the z-score. You may recall from a previous lesson that the z-score is your unknown value minus the mean all over your standard deviation. So we can use this formula to find the unknown value. So we would plug in 1.23 for z. We don't know the unknown value. The mean is 24. The standard deviation is 2.5. Now, to solve this equation, we'd multiply both sides, right, by 2.5. So that gives me x minus 24 on the right and 3.075 on the left. I would then add 24 to both sides, and my unknown value would be 27.075. That is our first example. Let's do another one. Jarrett is in the 9th percentile in height. At his age, the average is 39 inches with a standard deviation of 1.85 inches. What is Jarrett's height? So now we know the mean is 39, standard deviation is 1.85, and the probability is 9th percent, so 0.09. Look in our table, here's 0.09. So again, I come over and up, and my z-score is negative 1.34. Same process, I know that z equals x minus mu all over sigma. Let's plug in what we know. So negative 1.34 equals x minus 39 divided by 1.85. If I multiply both sides by the denominator, which is 1.85, those cancel out. I'm left with x minus 39 on the right and negative 2.479 on the left. If I add 39 to both sides, my unknown value, which would be Jarrett's height, is 36.521 inches, which makes sense, right? 9th percentile, which means he's under average. and average is 39. So we know he's got to be less than average. And that is playing with the normal distribution to find unknown values.